All right, so once again, thanks everyone for joining this webinar. As I mentioned that at Ideaport Riga, we do have a dedicated group of people who are researching and doing different prototypes for clients using generative AI. And as we do those activities, we learn more and more things about actual journey, about what it takes to get from very cool demo playground with interesting capabilities of generative AI to solutions that work in production. Just to tell you upfront, we have not succeeded yet to get anyone into production in that sense. And today I just wanted to share you the foundings or the insights that we are slowly gathering from these activities, and also show you the progress we are doing with our AI accelerator called Magnet AI, which is free and open source, and how actually it supports our journey, because we see that there are some challenges, and to address the challenges, we try to implement certain functionality in our accelerator. All right, first topic that I wanted to discuss here is where we are in terms of generative AI. So almost 2 years ago, everyone was shocked by ChatGPT and what can it do. And then there was all the memes going around. And this is how also we started the webinar last year about asking a user to ChatGPT about making a joke. And it says that the moon is like a flattened cheese. And users say, yeah, not funny. Can you give another one? And ChatGPT says, I will not take your job away. So now we are 2 years into ChatGPT era, and we see still that actually not much has changed. So what we see is that the sentiments toward generative AI is changing from something overhyped, remedy to every problem, like silver bullet solution to all the productivity issues we have had in our companies for many years, to actually pragmatic solution, which could be used pretty good in some selected use cases. And again, ideally supervised by an employee or by human, even though there are brave companies who are putting this technology in front of their customers. And I'm still really curious how they do that. More to come on that later, maybe this year. Okay, and I think kind of another thing, what explains this too high expectations toward generative AI is that somehow we started to use word generative AI and AI interchangeably. So basically it was like there is AI stuff with machine learning and neural networks people were doing for many decades. And suddenly here comes generative AI, which is inheriting all the great capabilities of all these other artificial intelligence approaches and is like super tool to address everything. And in fact, as you can see also from this slide from Gartner, I think kind of more and more this kind of research we're going to be getting is that not all AI evolves around generative AI, and generative AI is just one of the techniques what we can utilize. So there is a good article about the same topic. And then effectively, they also have a webinar. Gartner had a webinar 2 weeks ago, and here is a link to that where you can watch it on demand now. And one of the topics they've been discussing is which AI techniques is good for what they call like use case families. And again, here, if you see generative AI, it's pretty good at some, okay with others. I could maybe comment or disagree on a few things here. But obviously, for these use cases, generative AI is not good at all. And I think kind of the point that they are making is it's not that we have to use either of the techniques so that one rules them all and stuff, but instead we should see how we can apply all these different techniques together. And I don't know if Richard Napier is on the call, but he's a big fan of this AI approach. So Oracle Intelligent Advisor or Oracle Policy Automation, how it used to be called, is also considered AI technique. And actually combining these two gives you a pretty good set of capabilities. So that's maybe we're going to do more going forward. Okay, then I would like to go to the next topic about the stages this generative AI implementation takes place. And I think our first comment that I wanted to make is that actually it's no different from implementation of other application or technology or new application technology. So in our case, we all start with the play and learn, right? So we started to use ChatGPT, went to the OpenAI playground, interacted with the model through API, and then we took a deeper dive into some of the generative AI courses, like Oracle is offering now as well. I think kind of free certification is over, so good for those who were able to take this opportunity. And then also during this course, then you realize that, okay, if you want to build more complex solution, you have to use some libraries, and LangChain or Llama Index are those you would usually start looking into that. So a little bit of Python, a little bit of large language models, and off you go. So then obviously we start thinking, how can we actually make use of these techniques and of these large language model capabilities in our professional environment? So, and as we all come from CRM background, so how can we use it together with our CRM? What we can bring to the business users and stakeholders? And good ideas, we try to build smaller prototypes, so proof of concepts, on non-production data, of course, and just to see what is working, what is not working, and get some excitement from the business side. And the good thing is that actually CRM domain is one of those who will benefit from the generative AI the most, especially customer service operations. So there are plenty of those. And speaking of the use cases, we keep reclassifying this slide. So now we have added some implementation complexity. John wanted to add me the business value, but I think it really depends on organization to organization. So if you are a local company operating in the UK using only English language, translation doesn't make any sense for you. But if you are a multinational company with one of the centers in Romania and people are talking to you in different languages and you have to reply, even it could be like internal help desk for a company, right? Then, of course, this translation could be really handy. And maybe I will come back to the slides when we will do a demo session of this thing. Some of the use cases we've been showing before, but today we're going to show two new ones, like semantic search and also data explanation using generative AI. So that's what we will touch on a bit later, so stay tuned. And then when we convince somebody that it's a good idea to actually try to build something and launch it in production, as usual, we look at the low-hanging fruit type of use cases, basically those which we could implement pretty easily within really short time with very few investments and potentially big business benefits. And then to be safe, of course, deploy to production, but to a small group of users. And then finally, when we are happy about the results, and it seems to be working just fine, so we are brave enough to go for the full-scale deployment, taking these first use cases and deploying into the entire user base, and then gradually taking into the development more use cases, some more complex ones, but again, driven by the business case. So again, we look at the technical feasibility and cost implementation against the business benefits. And so far, that's no different. And I think the main point of this presentation for today is going to be that there are two big gaps when it comes to generative AI implementation from proof of concept to limited pilot. So it's gap number one. And then to limited pilot to full-scale deployment. That's kind of gap number two. So first, proof of concept to pilot. Basically, the problem there is such that with large language models, they have probabilistic nature, right? So similar to non-generative or this predictive machine learning models, which also recommend you something, but it recommends a certain probability. And basically, large language models, they work in the pretty similar way. And without going to the philosophical discussions or technical discussions, how it's done and is it like a bug or a feature of LLMs, we look from very practical point of view. And the problem we have that if I take the same prompt with the same input parameters and generate output, and then I do it again, in many cases, this output, same prompt, same parameters, are going to be different. And again, if I change parameters a little bit, but still I expect that the function of my prompt is going to be the same, it's suddenly on another input parameters, which are similar to those we've been building with, the output is a little different. So it's not working very great. And then basically we end up in situations that if you use LLMs, you cannot expect that your answer is going to be 100% great all the time. And of course, there's a question about hallucinations, like how do we solve those? And there are ways to do that because LLMs, despite everything you do RAG or anything else, you still have to do some work to make them behave correctly. But again, making sure that the quality of the results that you're generating is really good is one of the first problems that we need to address. So if you start with very basic, simple implementations of these Q&A services, asking questions over your knowledge base, you maybe get like 45% of the answers correctly or satisfactory, at least. And then you do some other things in order to get it to 80%, 85%, and then maybe you say that, okay, now we go into production live. And speaking about LLMs, are they bad or not? We perceive them like as a strange and like, how can it be? And I think it has to do with our sort of inherited understanding. Then when we work with IT systems, they're always deterministic. 1 + 1 is 2, 2 + 2 + is 4, 4 + 4 is 8, and so on. So anything else we do not accept. So it's like a bug, right? But maybe one thing that we have to learn about the generative AI is that they are like humans. So when I say something, I'm not always right. I can answer the same question differently depending on the time of the day. If I ask you all to look at these use cases for a second and then ask you to repeat what were these 9 use cases, I don't think you would do really great with this task. And LLMs, from that point of view, are not perfect either. But again, since we're not just giving up, right? So we just move on. And now we kind of move to solution part. So first part of the solution is that you actually try to, instead of making a single call to LLM and giving the results to the end user, we try to build and extend our pipelines and to build in the steps which make sure that the quality of the outputs are getting better. And we add some safety steps as well, even though if you look at the foundational models provided by Azure, for example, or OpenAI, they already bake into the API service all the safety and guardrails, which is good. I don't know about Oracle, but maybe it's the same. And then the second step, what we do a lot of prompt engineering. We optimize the parameters of every step of the pipeline. And just to give you an example, if you talk about this question and answer use case, which is called retrieval augmented generation, when you are asking questions against your internal knowledge base, actually it is pretty complicated process with a multiple step. Of course, first you have a knowledge store somewhere, and then, for example, you get PDFs, and the first job for you is to parse it. So how do you extract the text out of it? Of course, if it's just a plain document, it's very easy. When you start getting tables and stuff and pictures, then it suddenly becomes challenging. How do you actually deal with that? Then what you do is that because earlier models, they have context window for the prompt, basically how much data you can pass as your input parameter. And now you have content window on the Google models, which are really huge. But again, still you have to pay for all of these things. So you start chunking because you want to actually split your document into certain pieces so that you can feed it into LLM piece by piece and not like entire document. For chunking, there are also kind of differences how you do it. You can either say, I want to just cut everything at 1,000 tokens, and this is my chunk. You can do a bit smarter. Maybe you can just look for the end of the paragraphs and things like that so that it just not stopped or cut in the very weird way, but more intelligently. You can do that. There's some other techniques when you do semantic chunking. You look at every chunk compared with the previous one, and if they still belong to the same topic, like the similarity score is the same, you combine them as one chunk. So many different ways how you do that. Then embedding, basically what model you're going to use. Is it OpenAI Ada 2? Is it Cohere model? It's something else. Then vector store. I hope vector stores are performing everywhere the same. At least what I hope for, maybe not. And then some moving variables if you do just the embedding. So basically turning your internal knowledge base into these vector embeddings and store it in the vector store. And then you go to Q&A flow, right? So again, the process is, as most of you know, you take a question, user question, you do embedding, so you also convert it to this array of float numbers, same you did here. And then you typically do semantic search, similarity search. You compare this to the vector of the question with chunks in your vector store, which are also embedded. And then if they are similar, then you pick them so that you can use them as a part of the question and answer prompt. But if they're not similar, you don't touch them. And then if you talk about similarity search, when do you consider that this chunk is similar? Is like a one question. Is it like 75% similar or is 90% similar? If you get like 100 of them, do you pass all of them or you limit the number? Maybe you want to pass also the chunks which are close to the one that you picked up. So there are a lot of decisions you need to make for that. And if we take a step back, what is also becoming more popular, since a majority of the questions are, asked over and over again. So why don't we just look at the question first? And if we see that in our cache, there is similar questions. So again, what are similar questions? A big question. Sorry for that. But then if we see that actually we have a golden answer for certain question, why do we actually all bother with this entire flow? Let's just serve this answer to the user and that's it. So let's save money and time and keep the world greener. Okay, then there are re-ranking techniques as well. When you just did basic similarity search, there are other ways how you can find even better or sort the chunks in a different way using different model. Then you ground your prompt, you do your post-processing. Maybe you want to check for hallucination. If you define that it's hallucination, then regenerate everything. If it's not hallucination, you move on. How you define hallucination, what prompt you are using, it's all up to you. And only at the end, you serve the answer. So basically, even if I'm talking about, okay, here is my document, I have embedded it, and now users can ask question again that, as I try to illustrate here, there's a lot of smaller parts that this whole pipeline is consisting of, and for pretty much everyone, you need to make some choices and the decisions. And basically, from the practical point of view, or from solution point of view, what it means is that you have to do much more testing on different combinations of data and different parameters of your prompts or on your RAG parameters, and then you run evaluations. So you set your pipeline for RAG in one particular way, you fill in 100 answers, automatically on the background, you do this retrieval augmented generations on the background, and then you serve the results to the user, and the user can compare how good the answer generated by our RAG was, how good the answer generated by our RAG pipelines actually are, how helpful they are, how precise they are. And if you compare different combinations of these RAG pipelines, then you can see, okay, in this setup, overall it works better or not so great. Maybe we need to use one model over another model and all other things. And obviously, once you achieve decent quality of the outputs and everybody understands the limitations and the expectations are set and you deploy, it would be a great idea to monitor how your system behaves, what kind of answers it generates, and then you allow users also to rate it so that you get some kind of human feedback as well. And then I think you are okay to go and start using Gen AI in production. And then if you want to scale it, you hit another bump on your way to full scale deployment. And I think we discussed it before on some webinars and also in the discussions that large language models are called large for a reason, right? So they are really large and you need to have a lot of infrastructure to run those, to serve those. And as they are large, they are slow. And because they take a lot of resources, they're expensive to run. And then here we have basically two problems, right? So if I solved my quality problem by adding more and more steps into my pipeline, which involves not just single call to LLM, but several calls to LLM, maybe 2, maybe 10, depends how you set it up, it becomes too long for user to wait for the answer. So your user experience is ruined in a way that nobody actually want to use it. So I can go and find the answer myself faster than your system is doing that, or because I am working in the customer service for so long time, I know the questions to the answers by heart. So I don't even use this LLM because it's not perfect. In some cases, better than I am, of course. Maybe it keeps up-to-date information, but still, I'm not going to wait for it to come back. And then the second thing, of course, that the more calls you are making, the more data you add to the input of LLMs, and also if the output grows. Basically, most of the pricing models are based on the tokens consumed by the model, right? And how many its tokens generated. So if you go for the large scale, full scale deployment, this cost adding up, and again, the business case can get ruined as well. So maybe that's why we don't see generative AI implemented in all of the CRMs, and everybody's so excited about it. So I think kind of the way how to approach it is first that we need to implement comprehensive observability solution. In some of the cases, foundational model providers can give you the information about the execution time for every call and how much money you are spending on different things. But maybe you want to add more data to that. So what actually is a use case? What kind of the usage we're doing? Is it this use case or another use case? This model, is it expensive or not? And then I think the big change, what is happening now, is that companies started to look into the smaller models as well, which may be fine-tuned as well. So basically what's happening is that we realize that for a certain prompt, maybe categorization of customer inbound requests, you don't really need top model, GPTO or something. Maybe GPTO mini will do, or even something smaller is helping us. Obviously, for some other purposes, you might want to fine-tune the model so that you control more the output. And typically the way you do it, you take a smaller model, generate either your data or synthetic data by the large language model, and you fine-tune it so that it's really good on one particular task. And you don't need to pass so many examples as you do the prompt. That's what we can do today. And these are ways to address these problems. But I think also if we wait and see a little bit longer, if we see two trends going on. So one is on the sort of hardware side and another one on the LLM front. So first thing is that currently, when we talk about AI, we talk about NVIDIA, but you have other alternative competitors coming like grok.com, for example. From them, you can buy on processors, they call it LMUs or something. So the idea is that they're not optimized for training the model, but actually for inference or for generation piece of that. And for that reason, they are much more performant, they are much faster. And actually, if you do some kind of experiments on their platform, it's very fast and it's much cheaper as well. The only thing is that obviously, for example, the Grok, they are serving open source models only. So the best you get there is Llama 3.1, which is pretty good model, but you will not get the Cohere or Anthropic or OpenAI, which resides at other clouds, let's put it this way. And I think kind of the second thing that is happening more and more, so that the large language models themselves, they are becoming cheaper and faster as well. So if you compare the cost of GPT-4, the original GPT-4, which was released in March 2023, and GPT-4o that we have now, they are like 80% cheaper themselves. So you get this business case back, maybe in some of the situations. But also from the kind of engineering point of view, on one hand, they do start to allow prompt caching. So for example, if they have a longer context window and then you send there the data that you want to be there or prompts, you can kind of recall them from the server, not every time send it back and forth. So, and this is also impacts the cost of, and the latency, obviously, for running these Gen AI pipelines scenarios. Okay, and the conclusions that for these sections so far that I have is that what I wanted to demonstrate, right? So that implementing Gen AI goes way beyond making an LLM API call. It requires more sophisticated tooling that you need to have. Again, LangChain is really good. So they have a lot of capabilities. They also building their own platforms for running large language based applications, either on the customer environment or in the cloud. It's called Longsmith. But still, it is pretty developer oriented. So you have to know Python or in worst case, JavaScript. And also it has like many abstractions layers. So if you want to change something to customize it to work in your particular way, usually it is a bit cumbersome to understand how this whole thing is working. And then again, since we're coming from CRM backgrounds, Siebel, Salesforce, what else we have? If it is our CRM teams who are going to be responsible for adding features into the CRM applications, then typically we would prefer to use some low-code tools. But of course, we want to have an ability to customize functionality so that we can code some extra things to fit our unique enterprise use case. So maybe I will take a little break before I move to this more kind of demo type of presentation. As I was explaining before, as we work with different customers on this journey, so we try to add some of the functionality that helps us to overcome this gap. So we want to make sure that you can customize your prompt the way you want to. If you have this very sophisticated, you have control over many elements here. And this is what we are building in Magnet AI. And also, as we need to have the ability to do the evaluations, to run prompts and RAG pipelines on different data sets. So we also look at the ways how to automate it. So effectively, Magnet AI has building blocks. So it has like templates management so that we can create a library of different prompts we can then reuse. We have knowledge base embedding, and then we have different tool configurations. So now we have these RAG pipelines done in kind of no code way. And then next, in the middle of September, we will start looking more into the agent. So now we can code them, but we want to make them more configurable. So, and what I mean by this also, I will just jump into Magnet AI. So for example, let's do categorization. So this is prompt, which takes certain parameters or expects certain parameters from the user input and then returns a JSON back. So again, that was a prompt body. Basically, technically speaking, it's a system message. So you know that in most of the APIs, you have system message, user message, and then a system message gets back as the output. So this is like a system message that we have, basically telling that the user will provide you with 3 inputs: customer, email, sentiment, list of values, and your job is to create this output. So now it's set in Spanish. Here I can choose different models. Now they are hooked up to Azure, but in principle, we can bring in other model if you don't mind it, because usually this entire backend is running on one cloud. So now it's Azure, but we will port it to OCI during September. But then if you want to pass to somewhere else, to AWS or to the Croc, which is like really performant, then it's no problem to add the model, but it will travel through the internet. And then I think extra security questions are being asked in that way. But one of the reasons we're using Azure now is that the kind of the set of models is much larger there. Last time I checked, it was about like 157 or something, like both Microsoft, Cohere's, Mistral, and OpenAI, some Hugging Face, some other things. But on OCI, we have, again, what, Llama and Cohere, right? So not much. Okay, you can go on temperatures, usually token. Again, for the sake of testing, we added a tab where you can store your sample. So you paste it here, you run it, and you see what results are coming back. So, okay, Spanish is good now. If I change it to English, so I want this to be in English language this time, and kind of run it again. So I get result in English, right? And then if I switch it to Siebel, so there was email and I create service request based on that. And by clicking this button, I pass the data from the email. And then it populated for me type, sentiment, summary, detail, description, pretty much all these fields that we received back. Okay, so these were prompts. Speaking about the building blocks, we have the knowledge base embeddings. So the idea is that if I have, for example, a SharePoint site or Confluence page or something, then I'm able to do this embedding piece. So if you remember it, this like first pipeline, right? So that Basically, we say, okay, this is SharePoint, take it from the site, or this is Confluence, or this is like Salesforce knowledge base, take it from there, or if it's right now, take it from there. And then it does parking, chunking, and embedding and stuff. So, and then here are some parameters you can as well. I don't want to create for sake of time a new one, but you get an idea. So, and if I try it here, so I will take and ask questions, and then semantic search will kick in. And if I look into the details, that these are different chunks that we have here. And this is the first step you need to do, because the real power comes in this Q&A flow. And this is where you can manipulate a lot of stuff. So for one of the POC we're doing, we create the, and what I need to say is that we can do also for the knowledge sources like custom flows. For example, in this case, we just took to the service provider, telecom service provider website, and took the like helpline, which was in Latvian. And here we just say that, okay, this is my knowledge source that I have. We don't do semantic cache yet. So what is the threshold you want to have for different parameters? How many chunks you want to select, like top 5, top 10, up to you. Then when it comes to generation, which prompt you want to use to ask the system to generate the answer. So then we added this multilingual capability, because we found out that if you have a context in one language and people are asking the question in another language, it works. But if you translate the language before doing semantic search to the language which is original to your knowledge source, then the performance is much better. So then here we, again, have a prompt that detects the language. And then we say, okay, in which language the source is. And then there is a prompt which translates the question. Then there is little post-processing. Do we want to check if the answer is answered or not? Do we want to check for hallucination and stuff? And then some UI setting. And here is like a preview. Some of these sample questions, like to get users going, you can add here. And this is my favorite. How can I tell if my TV is a smart TV? What we'll see here is that it is doing this whole thing based on the configuration of this RAG. Then it gives back me the answers, which I can copy. And then it gives me also the links. Okay, in the preview mode, it's just chunk is what we see. But if I want to look at the document, I can go and see how you can find out if your TV has smart TV feature. And what we actually did just yesterday, basically this week, is this capability in Siebel that, let's say here I have a question from the customer, right? So they were not sure, let's say, if their electricity metering is switched off, do they still need to pay fixed fee for connection? So we can jump into this retrieval augmented generation right away. I think the better results would be if we turn this description into the answer, and then if we would do something else. But in this case, we just did it in the rough way, and it still to be working. Yes, you have to pay and stuff. And also, what I need to mention about this knowledge stores is that we have added capability that, and API as well, so that you can embed the data through API. So what happens here now is that we have a description of the problem, which we actually sent to one of our knowledge stores in Siebel. Let me just do, okay, service requests, yeah. So, and if I go to chunks, yes, these are basically the chunks, like row ID of the service requests and the embedded content. A lot of cases it's small, it's like still empty, but basically all service request records are here. And then once I did it, I can start using similarity search as well. So basically, if I click to this tab, similarity search, it will show me service requests with a similar description. So obviously, since this description is absolutely the same, so we have similarity score 1 for the same service request, so which makes perfect sense. But then there was other service request here. And for this service request, there was some kind of resolution. So there was basically explanation of what to do. And then there was something similar. You can see that if it's 90 something points, the answer is really similar. But then when it goes below, it just picks some other things, which is also about the payments, but basically how much time it takes for the money to arrive to the service provider. So you can see that they are similar, but not as similar as the first one, and the top similarity is on the top, obviously. Okay, this is what we added and that I wanted to show, like this semantic search on the service requests and RAG feature. Okay, again, just to repeat a little bit, we've shown before this panel, and maybe when I will be sending out materials, I will send you recording of the previous webinar where we play more with this panel, like with both with agents and Q&A stuff. But again, here I can ask the same question I've been asking before. In this, here is my TV, smart TV. If I ask it here, so basically it's like an end user experience. And basically like one what we call RAG tool, the pipeline configured for retrieval augmented generation. We call it like RAG tool, and you can configure, and this is how it's used. And then maybe a few more things from Magnet AI point of view. So that was RAG tool, and now we're working on what we call API apps, which effectively are iframes, which you can just open and embed into an application. So it has different tabs, which I configure. Maybe I'll shut down Siebel for now. I don't need it anymore. So which I configure here. So I have 5 tabs. So let's say if I want to add another tab, I can do it. Yeah, here. So I want to say that this is a RAG, and then I give it a name, demo. And if it's a RAG, I choose one of the RAG tools. So, okay, maybe Magnet AI demo. So now it's added here, and then it's also added in this, it should be at least, in this iframe as well. No, it's not. Maybe I need to save it. Yes, I do. Then I go again. Yeah, so it's here, and what are RAG tools? So basically I can either add several knowledge sources into one RAG tool, or to any tab I can add like several RAG tools or RAG configurations, but that's basically how it's done. And then I can play the demo. What are RAG tools? And then it's explain things. All right, going back. And then the other options, they are custom, what we call them custom. Basically, there is like a component you need to pass, but going forward, we will make it more configurable. And then one I wanted to showcase to you today is also going back to the use cases, which was about comparing data. So I wanted to just showcase this one. So basically, a common problem in telecom environments, or maybe somewhere else as well, is that the customer receive an invoice which is much larger than the previous one. And I'll just show you how these 2 invoices look. Okay. So basically, there's one invoice. It's for me. I can cut it out later. So basically, invoice Latvian language with some kind of table. One was for 74 euros, another was for 27, like what the hell. And then here we have a prompt, we call the prompt. So first, basically what it did, it just parsed these 2 PDF files, extracted all the values, and then we made a call to LLM, which is specified here somewhere, this prompt. So we call this prompt, and then it just, it's gone. And then it compares the data, and according to our prompt, it just explained me that first one invoice is with this number, with this date. The summary is such that the first invoice total is 27, and this is 74, and this is the difference. And then it goes and explains the reasons for the difference, why they are different. And then for every reason, it explains, like in the first invoice, there was this value, and then that value. And this is the main reason for invoice change, or some increase, that consumption was totally different. And there are some other, when I saved reserved capacity, so they charged me a little bit more for power maintenance, and there was some discounts which also became less. But this is how it explains the content of pretty unstructured data. Just copied the text from invoices and did comparison, and it works okay, even though if you get more sophisticated invoices, we need to go to fine tuning. And then maybe the last piece that I wanted to show today is that we have these evaluation jobs. So first, I want to show how I can, so basically I have 2 prompts for translating stuff. Okay, so basically these are files which have 10 parameters, and these are the questions in Latvian language. And then I go to evaluation job and say, I want to, on these 10 questions that I have, I want to test 2 templates for translation. One I use Cohere and another one GPT-4 Mini, and then I save and run. So then it will take me a few minutes to run it. Oh, a few seconds, sorry. Keep refreshing. And then I can download the results. So it's a CSV file. And here I can say, okay, this was this prompt template. So it used GPT-4 Mini, and this is like this model. And then I can see how did they do with the translation. So here I see that here did translate the name of customer service portal to like Montats. ChatGPT or 4.0 Mini model left it like in the original one. Here Cohere picked up ITV from somewhere, even though it's not here. Here again, Cohere talk something about Verizon, even though there is no Verizon in Latvia. So training data comes back with this. So without going further, I'd say, yeah, maybe I have to stick with GPT-4 Mini model for this task. So now again, it's manual mainly, but you can do it in bulk. You can call prompts in bulk. You can call RAG in bulk and get the results back. That's the idea. So to wrap up, so we have all this tooling available now. Basic evaluation for prompts in RAG, which I just showed. On the roadmap, we have observability. We have UI for adding more models because we want to really start playing with the smaller models, which are faster and cheaper. And then maybe add like advanced evaluation as well, so that we use LLMs to say this is a good answer, this is a bad answer and stuff. And then when it comes to the integration with CRM, so there are APIs for prompts, like when we needed to determine summary type, sentiment, and whatever else for the service request, we did it. For the embedding, when we push the description of the service request into the vector store, then RAG tool is available. And also using semantic search, we can build a particular example, VBC, Visual Business Component, on our API. And then we sort it so that the top results are on top. And then from configuration point of view, so now we have a native panel in Siebel, which I showed before, and now we are working on kind of a new version of it. But for other application, iframe is available as well. So again, some links to learn more about Magnet AI, link, discuss more details, email me, and options to engage. Since it's open source, we're happy to just give you the code and you fork it and you do further development on your own. Maybe not. Then another option is to take what we have for the deployment guidelines and deploy it in Azure, in your Azure environment. So it's yours where you can play and do experiments. Or if you don't have it, so we can have for POC, we can give our environment. So you will have access to Magnet admin and demo instance of Siebel and Salesforce where you can experiment and show your customers how a solution is working. Okay, with that, I will go to Q&A. Mikhail's licensing, it's free and open source. Talk to me. On-prem, maybe we will get there one day. So for now, we are looking at Azure because they have all their greatest models over there and stuff. Next stop is going to be OCI because we love Oracle so much. And then we will look at the on-prem deployments. So I think we know how to do it. There are models available, but that we need to play with. How is the cost of OCI Cohere models versus ChatGPT models? OCI and Surface appears to be quite cost competitive. This is a good question, and I think this is like for the next part when we really need to compare performance and the cost of the models and what smaller models are available and for what tasks. So I think it's a bit more sophisticated exercise we need to do. Okay, Dinesh, it is a good idea to incorporate logic to compare response from the model with customer claims, which is similar to previous PRs. See if the model was able to run and mature. Yeah, when it comes to learning, again, like technically speaking, we are not doing any learning. So we come the model as it is pre-trained for us. It went through all the post-training cycles and stuff like that. So we're not touching it. If you are referring to fine-tuning, I think at this stage, we really want to focus on the prompting, on using different models and tweaking all the parameters that I showed before. And again, if we really need to think really hard on the format of this output, then we would go and fine-tune things. And another use case, we're not there yet for like full-scale deployment, when we would need to take like a smaller models, generate data from the large model maybe with your twist, your company twist, and then would fine tune this small model and stuff. So, but for now, we're not retraining anything. So we're just using things as they are. Okay, if there are no other questions, it's time to say goodbye for now. We are going to come, like a whole team of us, both working with Siebel, OpenUI, and also Magnet AI, to Las Vegas next week. So hope to see some of you over there. With that, I think I will conclude the webinar. If no further question, just reach me through the email, you know it, and have a good rest of the day. Bye-bye.